Hello, here is another question on reaction mechanism. This is your chemistry tutor Akpeji Honesty. This question has bring issues to students, but with this video you will have a better view and understanding on this question. Let's look at it together. The when reaction mechanism is given to you, okay, just know that the most important thing you are looking for is the rate law, okay, from the mechanism. Okay, not just for you to write the overall reaction and then you now determine the rate law from the overall reaction. No, you need to use the mechanism to determine the rate law. Once you are able to do that, you must have answered question one, question two, question three in all of them, because in determining the rate law we shall touch all of this. Do you understand that? Okay, let's take this question and look at it together. Ensure you take your pen and follow what I will be doing here. The first question is write the overall reaction. Okay, how to write the overall reaction? I've told you, you add both equations together, all of them. I plus I2 plus I plus H2. I hope you can see. Then plus H2I plus I will give birth to what? 2I, as in this, plus what? H2I plus what now? 2HI. Please pardon me, pardon this space, okay? So from here you can see this, we have 2I here and you have 2I here. This I will cancel this 2I. Okay, you have H2I here. This H2I will cancel this H2I. Okay, to remain what now? I2 plus H2 to give I2 plus H2 to give what now? 2HI. This is the overall reaction. Okay, so the next question is identify the intermediate. In short, most time what you cancel out are the intermediates, okay, but you can also know them like this iodine is produced here, okay, and also consumed here. This it becomes the intermediate. Go back to my past videos and know what the definition of intermediates are, okay. Then also this is produced here and then consumed here also. This is also intermediate. So we have two intermediates for this reaction. Intermediates for question number 2 are I and H2I. Those are the intermediate. Then number 3, identify the rate determining step. Okay, the rate determining step, I told you, is the slow process, but I don't want to judge by that slow process only. I've already told you that your rate determining step leads to the final product. Okay, it gives you the product, and when you look at my rate, the overall reaction, what is the product you have here? Your HI. Then what is the product you have here? HI. That tells you that it is the rate determining step. That is one way of knowing. Another way is that it is the slow process. But we can have many slow process. Okay, but the question will not tell you the slowest process. And also note that it is not the last equation that used to be the rate determining step all the time. Okay, so that you don't cram, okay, unnecessarily, that every last reaction in every mechanism is the rate determining. That is not correct. So please understand that this thing is not cramming. It just have you to it requires you having a little understanding. Build on the understanding by solving questions, solving examples, solving exercises, listening to videos like this, and you get it done all the time. Okay, let's go to the last thing and identify the rate determining step. So this is my rate determining step. Why? My rate determining step H2I plus I to give me what? 2HI. That is my rate determining step. Okay, why? I cannot be writing. Why? It is simply because it is the step that leads to the final product. Okay, because it gives me the product in my overall reaction, and my rate times also give me the product. Another way is that because it is the slowest process in the mechanism. Okay, I go straight to the next question. Okay, that number 4, deduce the rate law from the mechanism. From the mechanism. So if we are taking it from the mechanism, you go straight to say, okay, look at me, K1, this will be K subscript of -1, it will be K2, it will be K subscript of -2, this will be K3. Do you understand? So we are going to take each of them now and write the rate law. So when you are writing the rate law from the mechanism of the overall reaction from the mechanism, I come again, deducing the rate law for the overall reaction from the mechanism. Okay, so if we are following from the mechanism, you are going to write the rate law for each step. For each step. So look at what I'm doing here now. For each step I come, I write the rate law for this step, both for the forward and for the backward. So for the forward, I have R1 is equal to K1 I2. Okay. Then my R minus 1, I have K minus 1, then I raised to the power. So this is my equation 1, this is my equation 2. Then I go to the next one, R2 will give me K2, the connotation of I, okay, then IH2, okay. Then my R minus 2 will give me, I hope you can see, just look at what I'm doing. Let me slant this a bit, okay. Okay, so you can see what I'm doing here. You can see that this R minus 2 from -2, I'll be taking this. It will be K minus 2. Then I have what? H2I. This will be my equation 3. This will be my equation 4. Okay, then the next one goes, which is my last one, which is R3, which will give me what? Which will give me what? K3 H2I, then I. This will be equation 5. Do you get it? So please pardon me. I will just have to slant it well. Okay, I will have to straighten it well so that I can be able to solve. So nothing concerns me again with the reaction mechanism. So I will be working with this. Now with this now, I want to apply my steady state. Applying steady state. So applying steady state, it will, I'm going to say R1 is equal to R minus 1. Then I hope you can see this and this will be equal, because if you look at the mechanism, they are in equilibrium. Okay, this one too will also be R2 is equal to R minus 2. So let's take this. So for R1, what do I have in R1? Which is K1 I2 is equal to R minus 1, K minus 1, I squared. Okay, so now what is my intermediate? My intermediate, okay, as required, it is my I. Okay, you can see, since my intermediate is I will make I the surrogate of the formula. So I'm going to have my I squared is equal to what now? K over K minus 1, then I2. Okay, let me call this equation C. I am making I the subject, but I want to leave it here like this, because now if I remove these two, this one will turn to 1 over 2. Oh, okay, and it does not affect the rate constant. But let's leave it like this first and solve further and see if there will be need for me to remove the 2. Okay, then now I've done for that, so I will do for this. For this, R2 is equal to R minus 2. Okay, you can see that. So that means my R2 is what? K2 I H2 is equal to what now? R minus 2, K minus 2 H2I. Having known that the second intermediate is H2I, I will make it the surrogate of the formula. So I have H2I is equal to what? K2 over K minus 2. Then I have what now? I, then H2. You can see. So this one will be what? Equation 7. Okay, so you can see that I have for this intermediate and this intermediate. Okay, and this intermediate, okay, I can have my I here, my I, so it means I can substitute this into this. Okay, so that we have I, but another way I can do it is just to take my rate determining step. Okay, this is my rate determining equation. Okay, remember from the reaction mechanism, this is my rate determining equation, and as it is my rate determining equation, I can just say I can substitute 7 into 5. Put 7 into 5. When I do that, when you are putting 7 into 5, what is 5? This. Then I will be having R3 is equal to what? K3. What is H2I? This is my H2I. I'll put that, which is K2 over K minus 2, okay, which is I, then H2. Then I have another I remaining, which is this I. Do you get me here? So that means I'll be having R3 is equal to K3 K2 over K minus 2. I. How many I do I have here? 2. So I'll be having I squared, then H2. This will be my equation 8. So that means here I still have I squared remaining that has not been substituted. I can just put 6 into 8. You see that my I squared is coming back now. It's coming back. So I can just say put 6 into 8. That means I'll be having R3 is equal to K3 K2 over K minus 2. And what is my I squared? Which is what? K1 K minus 1. Okay. What is my I squared? It is what? I2. I have I2, then remaining what now? H2. Okay, so I can say let K3 K2 K1 over K minus 2K minus 1 all equals to K. Then my R3 will be equal to what? R. That means I will have my R is equal to everything here will become K. Then I have I2, okay, H2. This will be my rate law. Okay, now if you compare this now to my overall reaction, is it not, does it not correspond? If you are going to write the rate law for this overall reaction, you will be having R is equal to K, concentration of I2, concentration of hydrogen and H2. Okay, that this is what you are going to get. I believe this is very clear to you, and if it is, ensure you go through it again so that you have proper understanding. Sure, better say write it out. When you write it out, you get it clearer. Okay, so I encourage you to share my videos to friends and family and chemistry students, chemistry professionals, teachers. Okay, share it with them, and then our chemistry world that may look difficult for some person will look simpler. Understand that this video, this YouTube channel is simply for chemistry. It's just all about chemistry, both theoretical chemistry and practical chemistry. But I have not started uploading practical chemistry, but sooner or later you shall be getting videos on that. And I tell you, students of the lower learning, like the secondary school students, you will find this video very, very helpful. Those who are writing UTME, JAMB, A-level exams, in short, this is the best video for you to watch. Thank you. I remain your tutor, chemistry tutor, Akpeji Honesty.